Hello everyone. So we have a good question from the topic of organic chemistry. This particular question mainly involves the concepts of the last part of organic chemistry, the carboxylic acid and nitrogen containing compounds, that portion. And let me tell you, this portion is very, very important for mains. Okay. Like last year, I had one question. It was just one question from that part. And it was from a very, very specific topic. Okay. And I will be covering that in this particular video. So yeah, let's get started. Okay. So this is what the compound, the initial compound looks like. CH2, CH2. There are four carbons, I suppose. Yeah, four carbons. Okay. So this has been exposed to precisely one equivalent of SOCl2. Okay. And after that, one equivalent of NH3, ammonia. Okay. So with one exactly like one equivalent of SOCl2, what will happen is that one of the COH, either one of them, will be converted into COCl. Okay. So there are four carbons, right? 1, 2, 3, 4. And in the end, we have got a COCl here and a COH here, right? And when we expose it to again one equivalent of ammonia, what will happen is that this COCl over here will be converted to CONH2. And you will find the detailed mechanisms of these in a good organic chemistry book, okay, or even in the internet. Okay, it's available for free. So yeah. So this is what P1 looks like. So let's go through the options once. And I think it is correct. Is it CONH2? And we've got four carbons over here. Yeah, it is correct. A is correct. Okay. Now let's go to P2. P2 mein, this is a Hoffman bromamide reaction, as you can see. Bromine and KOH, typical Hoffman bromamide reagents. Okay. And yeah, Hoffman bromamide में क्या होता है कि this CONH2 right here will be converted to NH2. Okay, so this particular process is called I don't exactly remember the name, but carbon, the number of carbon is getting reduced, right, in this particular process, and this is a very important method for reducing the number of carbon atoms in organic compounds. So this is what it will look like right now. This is NH2 and this is COOH. Okay, let's try and match the options once. NH2 COOH, and yeah, I guess this is correct as well. It looks familiar, right? Yeah. Now we are exposing this thing to Br2 and red P. This step right here is very, very important. Okay, this particular reagent, what it does, it's basically called alpha bromination. Okay, and see, for this particular compound right here, for this particular compound, this is the COH group. Now we know that while naming a compound, or okay, let's not get into the nomenclature part. So what alpha bromination does is, at the alpha position of the COH, that is this part, this is alpha carbon, this is beta carbon, right? At the alpha position from the COH group, a bromine will be added. Okay, again, you will find detailed mechanisms of these on the internet. And let me tell you, this reaction is very, very important. And this particular reaction, only this reaction was there in my mains paper. Okay, it was just one question, but again, this is 4 marks, and if you don't know what the reagent is, you will lose 4 marks, right? So yeah, let's match the third option, CHBr. Yeah, this is also correct. This is also correct. Now comes the most interesting part. That is, when we heat it, what will happen? Okay, it has been stated that intramolecular SN2 reaction will happen. And yeah, let me just try and show you what the mechanism will look like. So you see this nitrogen right over here. This nitrogen over here has got lone pairs of electrons, right? Okay, let me not show this over here. Let me show this over here. Yeah, this nitrogen has got lone pairs of electrons, right? And we have got a bromine group over here. Now, bromine is a minus I group, right? It pulls the share of electrons towards itself. It's a more electronegative atom than carbon. So, a partial positive charge is formed in this particular carbon. Okay, partial positive charge. So, what will happen is that, and this bromine, it's a decent leaving group, and it will be, yeah, it will be removed. Okay, this is how that this is what the mechanism looks like. And as you might have guessed, this is a cyclic compound. So just next when we have a COH, and we have got two hydrogen atoms over here from the NH2. So this is H, this is H, this is, and there will be a plus charge over here. Why? Because nitrogen is donating its lone pair of electrons, right? And yeah, this is what the final product will look like. This might not necessarily be the most stable atom, but again, that is what was asked from us, right? Because it has been written intramolecular SN2 reaction will take place. Okay, so okay, option D I think is wrong. Okay, because option D is wrong. Yes. There has to be a COH over here. Okay, so yeah, that's it from this question. Thank you.